Good afternoon, students. So today we are going to see about the divergence of in field theory. So it is expressions divergence. Okay. So in previous derivation or in the last derivation, we have seen the Gauss law to a differential volume element. That is, we have derived Q is equal to dou into dx upon dou x plus dou into dy upon dy plus dou into dz upon dou z into differential volume, that is dv. This we have derived in the last class. So, and also we know that this you can call as some equation number 1. We also know that Q is equal to, from Gauss law, surface integral S T dot ds. So this you can call it as some equation number 2. So these two equations we can equate. So, and the one more thing is, we want to make the dv as small as possible, means we can apply limit to this del v and make it tends to 0. So therefore by equating 1 and 2, we have surface integral S d dot ds is nothing but limit as del v tends to 0 or delta v, the dou dx divided by dou x plus dou dy divided by dou y plus dou dz divided by dou z into delta v. So this is the equation. So this equation I can slightly rearrange. Therefore, if I rearrange this, that is d into dx upon dou x plus del into dy upon dou y plus dou into dz upon dou z, I am going to get as limit delta v tends to 0. Surface, from equation number 2, I can write this as q upon delta v. So this is also nothing but limit as del v tends to 0, it is surface integral S t dot ds upon delta v. Okay, so this is the most important equation. You can call this equation as 3. Okay, so from equation number 3, we can also define that it is the divergence. So if there is a vector A, any vector A, it can be force, it can be velocity, it can be temperature, any factor. So its divergence or mathematical operation on A is a divergence, then we can write divergence of A is nothing but limit delta V tends to 0 integration surface integral A into ds divided by delta V, or this is nothing but dou Ax upon dou x plus dou Ay upon dou y plus dou Az upon dou z. So this is the one important equation we have to remember. Okay, so this is the divergence of A. A can be anything. It is a force, velocity, temperature, any gradient values. So we have divergence and convergence. So we know the divergence. Now what is convergence? Convergence. So consider any point or a small surface area. If the value of A is going outwards, the divergence is positive. Then for the same surface area, if the A is coming inside, so here the divergence value is negative. So this becomes the convergence. So then if both the values, the divergence is like this, then the convergence is like this, then the value becomes 0. Okay, this is the some physical meaning of the divergence. Then if I go for the one more factor, that is vector operator. The vector operator this is also called as del operator. So this is called the del operation or del symbol. So from divergence we know, that div of A is nothing but dou into Ax divided by dou x plus dou into Ay divided by dou y plus dou into Az divided by dou z. This we know, but this is a scalar quantity. This is the scalar quantity. So if you want the if we have two vectors and we want the multiplication of that or dot product of that as a scalar quantity, then we have to apply the del operator. So this del operator we can define it as dou divided by dou x into Ax. This is the vector. So dou by dou y into Ay plus dou divided by dou z into Az. So this is the vector quantity. So this you can give it as some equation number 2. this, let it be equation number 1. Then the vector A, the A vector is defined as, the vector A is defined as, this is Ax in the direction of Ax plus Ay in the direction of Ay plus Az quantity in the direction of Az. This you give it as some equation number 3. Okay. Then the dot product of equation number 2 and 3, what we are going to get? The dot product is del dot A. This gives what? See here, this is Ax into Ax will give you 1, Ay into Ay will give you 1, Az into Az will give you 1 value. Then rest of this Ax into Ay, then Ax into Az, this becomes 0. Then Ax into Ay, then Ax into Az, this becomes all 0. That the only remains is, the only remaining part is, dou Ax divided by dou x plus dou Ay divided by dou y plus dou Az divided by dou z. So only this equation number 4 you are going to get. But what is this equation number 4 is equal to? Or we can equate this equation number 4 like this, that is our del dot A is nothing but, this almost resembles the divergence of A. So this we are going to get. So if I make the operation del dot A, I am to get the scalar quantity. Okay. So this is about the del operation. So some observations are that del is a mathematical operator and need not be involved always in the dot product, and it may be operated on the scalar field to obtain the vector results. Then del operation does not have any specific form in different coordinate systems. Whatever may be the coordinate systems in which A is represented, the del dot A represents the divergence of A. These are the some of the observations we get. Then some divergence we require in the coordinate systems. So you can note down that for Cartesian system, the del dot A is nothing but divergence of A. So this is nothing but dou into Ax upon dou x plus dou into Ay upon dou y plus dou into Az upon dou z. So this is the Cartesian. Then for cylindrical system, if you go, so this will resembles like 1 divided by r into dou by dou r. Here it is same. Here it is remains the same. R AR plus 1 divided by r into dou A phi upon dou phi plus dou Az upon dou z. Okay, this is for cylindrical. Then if you go for spherical system, here it is remains same. So the value is 1 divided by r square dou by dou r into r square ar plus 1 divided by r sin theta dou by dou theta into sin theta a theta plus 1 divided by r sin theta into dou a phi upon dou phi. So these are the different forms in the system. If you go for Cartesian, this is the form. If you go for cylindrical, this is the form. If you go for spherical, this is the form. So when we go for solving the problems, then we will understand which coordinate systems we have to use and which formula we have to use. So while solving those problems, I am going to tell you which to use. So this is about the divergence and del operation. Thank you.